Hey everyone, and welcome to the second half of 5.3, which is net change. Get it? Net change? Okay. Last time we talked about the fundamental theorem of calculus, and we've talked about the integral. The real-world applications for this is that it measures change over an interval, but we haven't really spent a lot of time talking about real-world problems. We've mentioned it, but we haven't gone into the concept deeply. Remember that the integral is net change. What kind of numbers affect net change compared to total change? Negative numbers. Remember, 5 steps forward and then 3 steps back gives you a net change of only 2 steps because the 5 minus 3 is 2. The negative steps affect that. If you want total change, you have to do the absolute value of that, the absolute value of the integral. So it'd be 5, instead of 5 minus 3, it'd be 5 plus 3. Negative numbers affect total change. If there are no negative numbers, the net change is the total change. If it's all positive, then it's all total. But if there's any positive or negative, if there's any negative numbers, it stops it from being total change. Let's start off real simple. Suppose you're given velocity in feet per second. Do you have an original or a derivative function? You have a derivative function. Why is it a derivative function? Because velocity is the derivative of position. You have a derivative function. That's one way to think about it. A better way to think about it is it's also something per something. And the per means that it's a derivative. Feet per second means it's a derivative graph or derivative function. Write an integral that shows displacement over 5 seconds. Well, how do I get from velocity to position? I integrate. So I integrate my velocity equation. If I want to go for the first 5 seconds, what's my bounds? From 0 to 5. What if I want to know the total distance traveled? Well, I still integrate from 0 to 5. But what kind of numbers mess up total distance? Negative numbers. I want to make sure that none of my velocities are negative. How can I make sure none of my velocities are negative? I put an absolute value around them. Net change, total change. I don't know if my velocities are positive or negative, so I have to put the absolute value bars there. We always do position, velocity, and acceleration. Let's do an example that's not one of the physics problems. So this is not a velocity example. The function g of m models the rate that the bamboo plant is growing in meters per month for any given month m. So it's meters per month that a bamboo plant is growing. Is this a derivative or original function, and how do you know? It's a derivative function. How do I know? Because it's something per something. Something per something means it's a slope, and a slope is a derivative. They almost always give you a derivative function. What does this mean, and what are the units? If I integrate meters per month, then I'm back to meters. That'll give you the units. The units are meters. What does this mean? This is how much the plant's height has changed in 12 months or 1 year. Now let's stop and talk about that for a second. Does that mean how much the plant has grown total? Maybe. Can a plant grow negative? No, it can't. I mean, it's not. You can cut it negative, but it's not going to grow negative. So this one probably does mean total growth. Does this mean how tall the plant is? No. This is just how much it's grown in 12 months. What else do you need to know besides just how much it's grown? You need to know how tall it was to begin with. What does this mean, and how is this different than, let's say, this? This means it started at 10 meters, and then it grew for 12 months. So this means total height after 12 months. Why is it total height? Well, it's total because you can't grow negative, and it's height because you know how much you started with. This is how tall it was. This is how much it grew over 12 months. So if you add them together, you get the total height. Use some common sense. Understand the problem. The math is easy. The concepts are hard. Let's take a look at this one. This was a table. The following table shows the rate in pounds per week that a baby elephant is growing. Pounds per week. Yeah. Is this an original or derivative function? You should know it's a derivative function. Why is it a derivative function? It's a derivative function because of the per. Pounds per week makes it a slope. What does this mean in words? If you integrate pounds per week, you get pounds. That'll give you a good first clue. It's how much the elephant has grown total in 12 weeks. No, you can't really say total, can you? Why not? Could a baby elephant have a negative growth? Could he lose weight 1 week? Yeah, he could. I mean, maybe he didn't find food that week. So I can't say this. I can't say the total growth because I don't know if there's any negative numbers in there. What I can say is it's the change in weight over 12 weeks. Stick with change because you don't know if it's total or not. There are no negative numbers in the table, but there's gaps in the table. I don't know what's going on in week 2 or week 2.5 or week 2.65. Maybe he lost weight one day. We don't know. We can't guess, so we have to be specific. It's the change in weight over 12 weeks. How do you calculate the integral when it's a table? I can't do an antiderivative. I can't raise it to a power and flip it and put it in front. So how do I estimate an integral on a table? There's two ways. You can do LRAM or you can do RRAM. So we're going to do RAM of some type. The baby elephant weighed 85 pounds at birth. Find his weight after 12 weeks. Well, that's 85 plus the integral from 0 to 12, PW, dW. We just said we can't calculate that, but we can estimate it. How? With RAM. I'm going to let you guys do this. If you do LRAM, you would get 85 plus 126, which means that it's 211 pounds after 12 weeks. If you did RRAM, you'd still have 85 to begin with, but it's only 91 pounds that he's changed, so it's only 176 pounds after 12 weeks. Which one is right? Either one. We're using RAM to estimate because we don't have exact numbers. Why 85? That's how much he weighed. Why 126 and 91? That's how much we estimated he changed. So add them together and get your total. Okay? Let's use some more conceptual problems. We're just going to write what this means. If W prime is the rate of growth of a child in pounds per year, what does this represent? Well, if we integrate pounds per year, then I know we're at pounds. That gives you a good starting point. You know what the answer is? It's pounds. So it's from 5 to 10. So it's the change in weight in pounds from the 5th year to the 10th year. It's not how much he weighs at the 10th year. It's how much he has changed from the 5th year to the 10th year. An oil leaks from a tank at a rate of RT gallons per minute. What does this represent? Well, gallons per minute, if you integrate gallons per minute, you get gallons. Now let's think about this. Are there any negative numbers here? Can water leak or oil leak backwards? Can it come back into what it's leaking from? No. These are all the positive leaks, if that makes any sense. So I can say it's the total amount leaked over 120 minutes. Why can I say total? Because you can't leak backwards. You can't leak back into what you're coming from. But what about growth? Why couldn't I say total change? Because you could theoretically lose weight, but you're not going to leak backwards. A bee population starts with 100 bees and increases at a rate of that many bees per week. What does this represent? Well, what does the 100 represent? You start with 100 bees. It told you that to begin with. What does this represent? It represents the change in the bee population from, or I should say over 15 weeks. Over 15 weeks. So what does that represent if I put it all together? It represents the total bee population after 15 weeks. Now somebody's going to say, Mr. Ratliff, how do you know the bee population isn't negative? Maybe it went down. Hey, that's fine. What if that's a negative number? That's fine. It's 100 minus instead of 100 plus. But that'll tell you how many bees you have after 15 weeks. This tells you how many you start with. This tells you how you've changed. Add them together, it tells you the total number. This is a little complicated. If X is feet and MX are pounds per foot, then what's dmdx? So what's the derivative of pounds per foot? The derivative of pounds per foot is pounds per foot squared. If I integrate pounds per foot, so I'm integrating pounds per foot, what's that going to give me? Just pounds. So if I take the derivative, I get pounds per foot squared. If I integrate, I just get pounds. Just like velocity is feet per second, acceleration is feet per second squared, and position is feet. The concept here is pretty important. The relationship between the change over a given amount of time. Every AP test has one or two short answer questions that look like this. Usually one calculator and one non-calculator. One with an equation and one with a table. Be comfortable with the idea of change as an integral. Have any questions, come talk to me. Thanks.